Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at the integral of 1 to 3 of x natural log of dx. And you'll notice we have two parts to this stuck inside. We have an x and we have a natural log of x. When you have two functions that look pretty separate that are glued together like this inside the integral, we want to think about using integration by parts. So by parts, if you'll recall, means that we are going to figure out a u and a dv, and from that, then we calculate what our du is, our v, and we use the formula integral of u dv is equal to uv minus the integral of v du. So we're just rewriting our integral, and this is going to make our lives a lot easier. So there's two things, of course, that we're working with. We have our u and our dv. Those are the two things that we are going to start off by finding. And basically the dv, make this the most difficult thing in the problem. Ugliest part that we know the antiderivative to. In particular, we need to know the antiderivative of this because once we figure out what our dv is, we do have to calculate v. That is going to be in general, not always, but in general, that is going to be the way to solve pretty much anything by parts. So I'm going to rewrite our integral here just because I want a little bit more space here. We want to set up our u and our dv. The ugliest thing that we know the antiderivative to in this is just going to be our x, and I'll throw that dx in there because we don't know the antiderivative the natural log of x is just not going to be as, we're not going to worry about that. So our derivative of natural log of x is 1 over x dx, and our antiderivative for x is 1/2 x squared, and no dx on that. Okay, now we're going to use this. We're going to get our uv. So u is natural log of x. Our v is 1/2 x squared. This is going to be evaluated at 1 to 3 because we have bounds on this particular integral. So once we have that, and then we'll have our integral of v, 1/2 x squared du, and I'm going to put the 1 over x dx. All right, before we go further, let's simplify this a little bit. I'm going to first off put the 1/2 x squared first. I know this is a simple thing, but it just ends up looking better, and you're less likely to make an algebra mistake if your natural log comes second. Off of that, we are also going to cancel one of our x's here in our integral. The 1/2, let's pull that all the way out front because we can do that with constants. And then we're left with just an x dx. Notice how nice that is. Now, technically, we could start evaluating our first part right now. This 1/2 x squared natural log of x. I'm going to wait and do this all in one shot once we've taken our antiderivative here because it's going to just make it that much easier. So remember our antiderivative, add 1, divide by our new power, and we are evaluating from 1 to 3. And let's do one more step. We're going to just pop this all together, x squared, natural log of x, since we have the same bounds on this, 1/4 x squared, 1, 2, 3. And if you enjoy explanations like this, subscribe. I'm doing Calc 2 problems all spring. All right, so 1/2, and let's pop in our 3, our upper bound, squared, natural log of 3 minus 1/2 3 squared. And I'm going to put big brackets around that. This is the one place where I really enjoy putting the big square brackets in. because it allows us to keep things a little bit more separated. It helps us be very clear about what's going on where. All right, now we get to do a little bit of simplification here. Natural log of 1 is 0, so that means that this whole term here vanishes in that particular spot right there. We have 3 squared, which is 9, so I'm going to write 9 halves. Natural log of 3 minus 3 squared is 9 again, 9 fourths minus, and our first term disappears. Our second term is 1/4. Notice we have a double negative, so that turns into a positive, and we can write that out. So now we have 9 halves natural log of 3 minus 9 halves plus, or 9 fourths plus 1/4 is going to be minus 8 fourths. And we can rewrite that one more time to just clean this up just a little bit and write that as minus 2. And this is about as good as we're going to get for this problem. There's our solution, nice and tidy at this point. Thank you so much for listening.